Hi, this is Mr. Singh here. Today we're looking at transformers, which is part of the AQA physics syllabus. Before we start, 4 questions here. Quick retrieval, please. Pause the video here and have a go at these. Okay, so let's see how you got on. Number 1, what type of current does a dynamo generate? Is direct current. Number 2, does a dynamo use a split ring or a slip ring? For 1 mark, and it's a split ring. Number 3, how does a microphone work? That was worth 4 marks. There you go. And number 4, what is the national grid made up of? Cables and transformers. So, moving on. There's your 3 objectives. And the keywords are transformer, core, magnetize, potential difference, and power. Transformers. These change the potential difference of electrical supply. And there are 2 types, step-up transformers and a step-down transformer. The transformer that is next to a power station is a step-up transformer, and a transformer next to a home, a school, something like that will be a step-down transformer. So this is basically what a transformer consists of. You've got iron core, and then you've got a primary coil, and you've got a secondary coil. And you'll see there is a difference between the number of turns on a primary and a secondary. If you look at a step-up transformer, on a primary coil there are less coils compared to the secondary coil. This is a step-up transformer. Whereas if you look at a step-down, it's the other way around. The primary coil this time has more coils compared to the secondary coil. This is a step-down transformer. Now, step-up and step-down transformers are used in the national grid to increase the potential difference and decrease the current down the power line. This is done to reduce heating effects and means less energy is lost during the transmission. So how do they work? An alternating current is applied to the primary coil. If you use direct current, it wouldn't work. It has to be AC. Creating an alternating, so that would create an alternating magnetic field to be formed around the primary coil. That then causes the magnetic domains inside the iron core to line up. However, at this point, no electricity passes through. Don't forget, no electricity passes through the core. It's just causing the magnetic domains inside the iron core to line up. This is experienced by the secondary coil, which induces a potential difference by the generator effect, and so an alternating current output. So using that then, here's a transformer equation that you need to know. Potential difference across the primary coil divided by potential difference across the secondary coil equals the number of turns on the primary coil divided by number of turns on the secondary coil. And it can be written as you can see. So, transformers are almost 100% efficient. Therefore, we can assume that the power input is equal to the power output. As you'll know, power is I times V. So, using that, so the potential difference in the secondary times the current in the secondary equals potential difference in the primary times the current in the primary. So here are 4 questions you need to answer then. So pause the video here and have a go at these using this equation. You'll need to rearrange this equation also. Let's have a look at the answers. Let's have a look at how you do. So the first one, a transformer has 50 turns on the primary. The output voltage was 250 volts, and the input voltage is 500 volts. How many turns are there on the secondary? Well, so on the primary you have 50 turns. This is what you're trying to work out. The primary voltage and the secondary voltage. So if you put it into the equation and you rearrange, you get 25 turns. Second one, number 2, a transformer has 60 turns on the primary and 180 turns on the secondary. What is the output voltage if the input voltage is 75? So again, the primary 60 turns, secondary 180 turns. The primary voltage is 75 volts. The secondary voltage is what you have to find out. So rearranging the equation, you'll get 225 volts. Next one, a transformer has 1,000 turns on the secondary. The output voltage was 100 volts and the input voltage is 25 volts. So how many turns are there on the primary? So again, this is what you're trying to work out. The secondary number of turns on the secondary is 1,000. The primary voltage is 25. The secondary voltage is 100 volts. Rearrange the equation again and you should get 250 turns. A travel adapter has a transformer in it. The transformer is able to step up 115 volts mains electricity to the required 230 volts. If a device has 5 amps running through it, what is the current drawn by the transformer from the mains electricity? So, you can see that. This time, the voltage, the primary voltage is that, the secondary voltage is that, the secondary current is that, and you're trying to find the current in the primary. So rearranging the equation again, you get 10 amps. Here's a past question. Figure 1 shows the construction of a simple transformer. Why is iron a suitable material for the core of a transformer? It's worth 1 mark. Tick 1 box or put a cross in 1 box. There you go, because it's easily magnetized. A student makes 3 simple transformers, J, K and L. Figure 2 shows how the potential difference across the secondary coil of each transformer varies as the potential difference across the primary coil of each transformer is changed. How can you tell that transformer J is a step down transformer? 1 mark. Because the potential difference across the secondary coil is smaller than the potential difference across the primary coil. Each of the transformers has 50 turns on the primary coil. Calculate the number of turns on the secondary coil of transformer L. Transformer L. So calculate the number of turns on the secondary coil of transformer L. Okay, so there you go. And that was worth 3 marks. And that ends our lesson on transformers.